this video built-in string methods in Python. But I will do one or two sort of alternatives using regular expressions, though I won't do it sort of maybe I'll do a detailed video on regular expressions at another time. So I'll do a little bit just to sort of show that they exist and how they're different than these built-in pure string methods. Okay, if you want this code, it's at this URL seen here. So I start off with just some crazy long string, which has small letters and capital letters, spaces, and some punctuation, and what have you. Okay, so one of the methods is lstrip to take white space away from the the left end of the string. And I'm going to print it out with start and end sort of sandwiched between, so you will see, and there is some white space at the beginning and some white space at the end, and then here I had, now this was sort of interesting, this will show up later, like when writing this, I was hitting the tab key, but the Visual Studio or whatever produced this as multiple spaces rather than actual tabs. So that's, you see that here in this little dot notations that you see here when I highlight it, and that will pop up, or I will replace space and it will replace those even though I generated them with a tab key. Okay. So I guess I would have to really test a tab. I probably have to either paste it in from some external device or read it in a file which had a tab. But here, this was made by tabs, but it's not true tabs. Okay, so I'm going to strip off the left end and show it start and end. So let me just run it and then scan through the results. So here is the start and end, and you can see that I got rid of the start, got rid of the starting spaces with lstrip, but not the beginning. And I put that, one thing you have to watch with methods is, do they affect the string or just a copy of the string? But because I wrote my code as my string equals my string dot lstrip, it did, even if it is affecting a copy, which it probably is, I assigned that copy back to the original variable. So it is sort of a more permanent change. And then I am doing the same down here with rstrip. So you can use just strip, which I think will do both ends, but I decided to break that down into lstrip and rstrip. And so here, down at 9 and 10, I applied rstrip, and then again, so then it didn't take away all the spaces, but it's taking away spaces at the beginning and end. Okay. Then I used the method capitalize, and once again, here I am assigning it back to the variable in question. And there is a dot lower, which will put everything in the lowercase. There's a dot upper, which will put everything in the uppercase. And then there is, and then there's another one whose name I can't remember off the top of my head. And then there's capitalize, which will take the first letter and capitalize it, and lowercase everything else. So I produced this. So there, and then I print that in line 13. So here's my very first character, H, capitalized now, and everything else moved into lowercase. So it doesn't have any understanding of like where my sentences begin or end or anything like that. But if you had just simply like a name, you wanted it, the first letter capitalized. If I had applied capitalize before I stripped off, then it would be looking at the first character, which was a space, and then would have not do any capitalizing because the first variable, the first character it encounters is not something that could be capitalized as if it were a space. Okay, but I had already stripped that off, so then capitalize makes sense. So there's lower, all small letters, upper, all capital letters, capitalize, begin with a capital, and all smalls. And there was another one that I remember reading, it sort of said, I think they compared to lower, and it's sort of, they kind of does a better job. I didn't do any testing of that here. Okay. Then I'm going to next use the find method, and I'm going to compare this to JavaScript index of. So it's going to look, and JavaScript has two. This would be the string index of, so it's going to look for a substring within a longer string, and it is. It's going to, if it finds it, it's going to tell you the index. It's going to tell you if it finds multiple. If there are multiple versions, it's going to find the first one, starting on the left, and give you the index, and that index is 0 based. So I'm going to look for first the word here, which is at the beginning, so it's going to give me an index of 0. Then there is the word we somewhere in there, pretty early on, so that should have a very low index. I'm going to find the word is, which is this is, so maybe a third of the way through. I'm going to use a sort of alternative version, rfind, and that is going to find something from the other end. So it's going to find this is way out here. And then I'm going to look for something that's not in there. So I'm going to look for poop and not find it. And sort of the standard sort of index of thing to do is to yield a -1 to say I did not find it. So let's see the results down here. There's the find stuff. Make a little bit more work for this output. Here's the find. Here was found at 0. B was found at 5. The is was found at 29. The is, starting on the right-hand side, was found at an index of 93, and poop, which was not found at all, was -1. Okay, I'm looking at the replace method that comes with in the string class, and so I'm going to replace ing with capital ing. And again, this I'm not doing as I was up here, sort of applying a method and then setting it back. I'm not doing that down here. So when I do this replace, it makes the replace, I believe, just in a copy. Confirm that. So here I'm replacing little ing with capital ing. So here it is. Here we go, testing capital ing. This is my crazy string ing. So it did multiple replaces. So it did a global replace. But then down below, my ings are small again. So it made the replace on a copy and not on the original method. And now I'm placing a space with nothing, and then here I am. And I did already. I had produced some of the space in the middle with this in this. It's nuts. And here I hit a tab key, but it didn't really write it in Visual Studio Code as tab. It just sort of inserted a bunch of spaces. So when I did this replace, it got rid of all the space. So here you can see all was based on. Okay. And I'd like to sort of come back to this and play more, play with the regular expressions, and I'd like to play more with regular expressions and sort of talk about getting rid of numbers or getting rid of letters or getting rid of spaces or getting rid of punctuation. That's more for a regular expression video. Okay, so but that was replace. So sort of for simple strings, regular expressions are for patterns, but for replacing a particular string, there is this replace method. Here I'm using the count method, so I'm here finding how many times a substring occurs within a longer string. And so the word we occurs once. So here we go testing. There's no other we's. But when I did the count for is, it came up with 3. So this is there. So this has an is in it, and is has an I in it, and then is tabs. So there were 3 occurrences. And then I was going to work with is as a word, and so I could do one approach with just the accounting version would be to use space is space, but I can also in regular expressions do it in a different way using what's called a word boundary. So I'm just showing you 2 things that I did above, but with a regular expression version, just to sort of show that it can be done. But these are not string methods, so I'm sort of going outside of the topic of string methods and go to regular expression methods. So you would have to bring in the regular expression, the RE class, and then the sort of equivalent of count used to use the regular expressions findall. And then here's my regular expression. This \b means that it's a boundary, a word boundary. So it should, the word should be starting is and ending is. So just be the word is and not the is within the word this. And if I find them all and then find the length, so I will find them, they'll sort of produce maybe a list or something that affects something multiple, and then I am getting the length of that thing. So that's effectively counting. So we see down here the regular expressions, and I'm getting 2 of them because I did it again, use the pattern to find it as a word, to find it as a word boundary, so not the is within this. And then that was sort of the regular expression equivalent of count, and there's also sort of a regular expression equivalent of replace, which is a sub. So I can use re sub and then substitute again, look for a pattern. I'm using is again, and I'm replacing it with capital BE and put it in my string. And then here I am. This be my crazy string, the white space be tabs. Okay. So that is a regular expression sub, which is a fancier version of replace. But again, it does not affect the original. If I print out my string, here's my string. So that substitution of is to be did not really happen. Okay. What other games can I play with just built-in string methods? There were lots of is methods. Is the string that you read in a number? Is the string capitalized? Is it small letters? Is it? There were lots of is. I didn't demo any of them. I didn't demo everything there was. Okay. But here now I'm playing with a multi-line string. So I'm using the triple quote. So I call the variable poem, and I set that equal to quote, quote, quote. And then I wrote out poem Mary Had a Little Lamb, and I am then printing that poem and then a backslash in. So that is this first version of Mary Had. So here's multi-line stuff, and here's Mary Had a Little Lamb, and so we got this far, and that is the just printing out the poem as it is with multi-lines. And then there is a split, breaks up something on a delimiter, and split lines in particular is breaking it up on end of line characters. So I have this multi-line string, and now I can use split strings to break it up and have sort of a list with four individual lines in it, four strings. And then I also wanted to find, so I'm looping through the string. So this is, I didn't confirm this by printing its type, but I'll say it's a list. And so I'm looping over the elements of this lines list, which are the individual lines, and I'm printing them out with the word line in front. So that was here, line, 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 just to sort of say, okay, I'm introducing something on each line, so that means I do have it indeed as individual lines now. And I'm also finding, I introduced a variable called line max, and I set to 0, and then each time I'm through the loop, I'm getting the maximum of the line max so far, and then the length of the line, and I'm stripping it of any white space I might have at the end of these lines. And I'm finding sort of the longest line that way. Okay. And then I'm almost done here. I wanted to play with some methods, again, built-in methods for built-in string methods. And so I have these lines. It was this list of lines I got from strip lines, and I'm looping through them this time, and I'm using taking the individual line, stripping it of any white space that might be hanging about, and then using the center method. And I'm using, I wanted to know how many, that's why I figured out what the longest line was, and it was 30. So I went up with like 45. And so I want to center it around 45. And so here's the centered version. So I'm writing this poem where the lines have different lengths, but they are all centered using this center method. And then I did it also with rjust, which is sort of right justifying. So then that was down here. So all the lines of the poem are right justified, so they line up on the right hand edge. And each line is decided to take 45 characters. So, and we've stripped it so there are no spaces, odd spaces at the end, and then we lined it up to take up 45 characters with our string being on the right hand edge. So that's what I want to show you here, just playing around with some of the built-in string methods of Python, and then a little bit of straying into regular expressions. Thanks for your attention.